Hello, I'm Shabaz Abid. This is General Physics 1, Lecture 1, and in this lecture, we are going to talk about units. Units give a meaning to any measurement we take. For example, if I have measured the length of the table and the length of the table is equal to 5. 5 doesn't mean anything alone, but if I say that the length of the table is equal to 5 meters, so now anyone can understand my measurement. We are going to choose SI units system in this course, and three of the fundamental dimensions which we are going to use in this course are length, mass and time. We have to stick to the base units in for each of these dimensions, and in the SI unit the base unit for the length is meter, denoted as small m. Mass has a base unit of kilogram, denoted as kg, and the time has a base unit of second. So in any calculation we have to make sure that we have meter for the length, we have kilogram for the mass, and we have second for time. There are some types of units which are derived from the base units. By combining different base units we can actually get the derived units. Now for example, one of the very famous derived unit is actually Newton, which is actually representing a force, and we are going to discuss a force in the later chapters. Now the force unit is equal to Newton, and 1 Newton is actually equal to 1 kilogram meter per second squared. There are other types of units which we are going to use in the later chapters. One is known as joule, which is actually a unit of energy, and its symbol is J. With respect to the base units, 1 joule is equal to 1 kilogram meter square per second squared. The unit of power is watt, denoted as capital W, and 1 watt is equal to 1 kilogram meter square per second cubed. The unit of pressure is Pascal, and it is denoted as PA. 1 Pascal is equal to 1 kilogram per meter per second square. So now you can see in all of these derived units we have three fundamental base units combined together to create one derived unit. If you look at the name, I have not written the name starting with the capital letter. Why? Because these units are named after someone. So we always write the name with the small letter of the name of the unit with the small letter. So these are some of the derived units. There are several derived units, but we are going to use most of the time in this course Newton, which is a unit of force. Okay, and we are also going to use joule, which is the unit of energy. In order to do the operations with the units, we have to make sure that we do it correctly. So if we want to add or if we want to subtract any two units, we have to make sure that they both have the same units. Both the numbers must have the same units. Now example 1, if we see that 10 meter can be added with 5 meter because they both have the same unit, so the overall answer is going to be 15 meters. But if I say that if I'm going to add 10 meter with 5 centimeter, it's not going to give me a correct answer. In this case I have to change one of them to create same units. I have to convert one of the unit to change the unit from maybe centimeter to meter, or maybe this meter to centimeter, and then add them together to get the total answer, maybe in centimeter or maybe in meters. In the case of the multiplication, if we are going to multiply two different two units which are identical to each other, we are going to add their power. So for example, if we are multiplying meter with some meter, we are going to get meter square, and actually this is a unit of area. This is actually a unit of area. So if we are going to multiply with two different units, we will not multiply, or sorry, we will not add their indices. We are going to basically write them alone with their powers. So for example, if I am going to multiply the meter with the second square, I am going to get the overall answer to be meter second squared. In the case of the division, when I am going to divide the two identical units with the same power, it's going to give me a dimensionless quantity. It does not have any unit. So in this case, if I'm going to divide 10 meters by 5 meter, I'm going to cancel out these 2 meters, and 10 divided by 5 is equal to 2. So it is actually without any unit. For example, if I'm going to divide the identical units but their exponents are different, in that case I have to subtract the power. So for example, if I am dividing the meter cube by meter, I can write the meter in the denominator to be meter to the power minus 1. So I'm going to say that meter to the power 3 minus 1 is actually equal to meter square. When different units are divided, the unit of the denominator actually adjusts itself. The power adjusts itself accordingly. So for example, if I'm going to divide the meter by second, and it's in the denominator, we can write it as meter second to the power minus 1. In certain times we are measuring something, and that measurement is maybe too small or maybe too large with respect to the base units. So in that case, we might have to use submultiple units, or we might have to use multiple units. Now what is a submultiple unit? It is actually a smaller scale or a fraction of the base unit. Now for example, if I'm going to say that the some length is equal to 0.005 meter, it is not convenient to mention this number with the base unit. So we can actually say that it's equal to 5 millimeter. Okay, it is equal to 5 millimeter. This is an example of the submultiple unit. In the case of the multiple unit, this is actually for a larger scale of the base unit. Now for example, if I'm going to say that 1000 meter is a very large number, we can actually squeeze it down. We can squeeze it down and we can say that it is going to be equal to 1 kilometer. So it's used for the larger scale. So some multiple units are used for the smaller scale, and multiple units are actually used for the larger scale. Here are some of the most common examples of the submultiple and the multiple units here. The mega and the kilo are an example of the multiple units. Centi, milli and micro are an example of submultiple units. Their symbols are mentioned here. Mega is denoted as capital M, K is kilo is small k, centi is small letter C, milli is small letter m, and the micro is denoted as a letter mu. Mega means 10 raised to the power 6, which is actually 1 million. So how to read this table? This is very important. 1 million of any base unit is actually equal to 10 raised to the power 6 of the base unit. In other words, it is 1 million of the base unit. So 1 million of any base unit is equal to 1 million of the base unit itself. So for example, if I have kilo with any base unit, so 1 kilo of any base unit is actually equal to 1000 of the base unit. Centi of any base unit is actually 10 raised to the power minus 2. In other words, it is 1 over 100. Milli of any base unit is actually 10 raised to the power minus 3 of the base unit itself. So it's 1 over 1000. Micro of any base unit is actually equal to 1 over 1 million of the base unit, which is actually 10 raised to the power minus 6. This is a very important statement. If we are going to solve any problem, we have to make sure that we change the multiple and the submultiple units into SI units. So for example, if I have centimeter mentioned in a question, I must convert it to meter, which is the base unit of the length. So we have to make sure all the dimensions, which are length and the mass and the time, must have a unit of meter, kilogram and second. So in order to convert these different types of units into a base unit, we are going to use a method which is known as a factor label method. Now in the case of the factor label method, we are actually going to multiply our given unit with some conversion factor. It can be one conversion factor or it can be multiple conversion factor multiplied to get our desired unit. Now what is actually a conversion factor? The conversion factor is actually a ratio of two similar quantities. It is a ratio of the two similar quantity. Now what do I mean by two similar quantity? It means that both are equal to each other, that they are equal to each other. So it means their ratio is going to equal to 1. It's going to be equal to 1. Now my question is, can 1/24 ratio be equal to 1 numerically? You will say that it might not be equal to 1, and it is actually not equal to 1, because 1/24 is not going to be equal to 1 mathematically if I'm just going to mention it as a number. But if I'm going to say that one day is equal to 24 hours, if I'm going to divide both sides by 24 hours, it's going to give me 1 day over 24 hours is actually equal to 1. So it means that this is a conversion factor which has a ratio answer equal to 1. Okay. In other case, for example, if I'm going to divide both sides by 1 day, I'm going to get 24 hours over 1 day is equal to 1. So this is actually a meaning of a conversion factor. The conversion factor which have different unit, but they are equal to each other. 1 day actually means 24 hours. So the ratio is going to be equal to 1, and conversion factors are going to be used to convert one unit to another unit. This is a fundamental rule for the factor label method. Starting with your given unit with its numerical number, we are going to multiply with the conversion factor. Now the goal is we have to make sure that we arrange the conversion factor in such a manner that we cancel out the given unit, and the remaining is going to be a required unit. So our final answer is going to be whatever was required. We can use more than one conversion factor to achieve our required unit. So it does not have any limitation. We can use multiple conversion factor to actually achieve our required unit. Let's start with some examples, and we are going to discuss the examples related to the dimension length. So I have taken this table from a book which is Physics for Scientists and Engineers, and in this table they have actually given us all different types of submultiple and multiple units. One note I have written here, that when you have a 10 raised to the power 0, it actually means base unit. Now let me give you an example. 1 meter of base unit is actually equal to 10 raised to the power 0 of the base unit. So it means 10 raised to the power 0 means what? It's actually equal to 1. So it is actually equal to 1 meter. So before we move to the example, let us understand this table. 1 kilo of a base unit is equal to 10 raised to the power 3 of the base unit. Let's do an example, for example, of the submultiple unit. 1 centi of the base unit is equal to 10 raised to the power minus 2 of the base unit. 10 raised to the power minus 2 means, in other words, 1/100. 1/100. Let's see the example 1. convert 55 kilometer to meters. Convert 55 kilometer to meters. Now you can see we are converting the kilometer to meter. So come back to this table. 1 kilo of meter, base unit meter, is actually equal to 10 raised to the power 3 of meter. Again, 1 kilo meter is equal to 10 raised to the power 3 of the meter. So 55 kilometer, this is numerical number with its unit, so it's 55 kilometer. We have to arrange a conversion factor in such a way that we are going to cancel out the kilometer with the kilometer, and as I have mentioned, 1 kilometer is equal to 10 raised to the power 3 meter, which is actually what, 1000 meters. So kilometer cancels out. 55 multiplied with 1000 meter is going to give me 55,000 meter. Example 2 of the length. Convert 625,000 centimeter to kilometer. Again, come back to this table. 1 centi of any base unit is equal to 10 raised to the power minus 2 of the base unit. 1 centi of any base unit is equal to 10 raised to the power minus 2 of the base unit. So 625,000 centimeter, I have to again arrange a conversion factor in such a way that I am going to cancel centimeter with the centimeter. So my first goal is to convert submultiple unit into a base unit, and then from the base unit to the multiple unit. So 625,000 centimeter multiply with 1 centimeter of any of the 1 centimeter of the 1 centimeter is actually equal to 10 raised to the power minus 2 of the meter. So if I'm going to cancel out centimeter with centimeter, I will get 10 raised to the power minus 2 meters. So this number is multiplied with 10 raised to the power minus 2 is 6250 meter. And again, from the base unit to a multiple unit, 1 kilometer is actually equal to 1000 meter. Again, come back to this table. 1 kilo of any base unit is actually equal to 10 raised to the power 3 of the base unit itself. So meter cancels out. 6250 divided by 1000 is going to give me 6.25 kilometer. We can solve this problem in another fashion. As I have mentioned, 1 centi of any base unit is equal to 10 raised to the power minus 2 of the base unit itself. 10 raised to the power minus 2 is actually what, 1 over 100. So 1 centimeter is actually equal to 1 over 100 meter. If I am going to multiply both sides by 100, we will get 1 meter is actually equal to 100 centimeter. So I can solve this problem as, instead of writing 1 centimeter, I wrote 1 meter. So now 1 meter is actually equal to 100 centimeters. So I am going to cancel out the centimeter with the centimeter. I will get the answer as 6250 meters. And again, from base unit to a multiple unit, 1 kilometer is equal to 1000 meters, and meter will cancel out. I am going to get the same answer, which is equal to 6.25 kilometers. Example 3 of the length. Convert 0.000004 meter to millimeters. So again, in this case, I will write whatever is given to us, this number, and the unit is meter. I have to arrange a conversion factor in such a way that I cancel out the meter. Now I have to refer to the table to get the relationship between the millimeter and the meter. So 1 millimeter is equal to 10 raised to the power minus 3 of what, meter. Okay, so 1 millimeter is equal to 10 raised to the power minus 3. Meter cancels out. If I divide this number with 10 raised to the power minus 3 is 0.004 millimeters. I can solve this similar to what I did in example 2, we can say that 1 millimeter is actually equal to 1 over 1000 meters. So if I multiply both sides by 1000, I'm going to say that 1 meter is actually equal to 1000 millimeters. So if I multiply this thing, and I will say that 1 meter is equal to 1000 millimeter, I'm going to get the exact same answer. By cancelling out the meters, I'm going to get the required unit as 0.004 millimeters. So this is the example again related to the length, and again we just have to make sure we use a conversion factor to cancel out the given units. Now let's see the examples related to time. How many seconds are there in 1.5 hours? So again, in this case, we can directly use our conversion factors, because we know how much is 1 hour equal to and how much is 1 meter equal to. So 1.5 hour, which is actually our numerical number with the given unit. So this is 1.5 hours. We have to convert the hours to seconds. So in this case, 1.5 hours multiply with 1 hour is how many minutes? 60 minutes. So 60 minutes are at the numerator and 1 hour at the denominator. Hour and hour will cancel out. Then again we have to convert we have to cancel out the minute. So 1 minute is actually equal to how much? 60 seconds. So it's going to be 1.5 hour, or basically 1.5 multiply with 60 multiply with 60, I'm going to get 5400 seconds. Another example, how many seconds are in 7 years? The symbol of an year is A. So 7 years multiply. 1 year has 365 days, assuming it's not a leap year. So 1 year has 365 days, 1 day has 24 hours, 1 hour has 60 minutes, and 1 minute has 60 seconds. So you can see that all of these units are going to cancel out. All of the given unit is also going to be cancelled out, and again these units are going to cancel out, and we are going to get the final answer in second, which is this much bigger number. So 7 year has this much seconds. Convert 600 minutes to hours. So again 600 minute is our numerical number with the given unit, and the unit is minutes. I have to convert to an hour. So it's going to be, the conversion factor is arranged in such a manner that I'm going to cancel out the minute with the minute. So again 1 hour has 60 minutes. So again 600 divided by 60 is going to give us 10 hours. Example 7, 8, 9 are related to mass. So first example is convert 500 gram to kilogram. 500 gram is given to us. 1 kilogram is equal to how many grams? Again we can see that it's kilo. So 1 kilogram is actually equal to 1000 grams. So 500 divided by 1000, and the gram is going to cancel out each other. We are going to get the answer as 0.5 kg, kilograms. Convert 2 kilogram to grams. 2 kilogram is given to us. Kg cancels out. 1 kg is actually equal to 1000 grams. So 2 multiply with 1000 is going to give us 2000 grams. Convert 3 tons. Now in some cases we might have to use a larger scale for the mass. So 1 ton is actually equal to 1000 kilogram. You might have heard the word kilogram in many different scenarios. So 1 ton is actually equal to 1000 kilogram, and its symbol is actually T, small letter T. So 3 ton is whatever is given to us. 1 ton is actually equal to 1000 kilogram. So 3 multiply with 1000 is going to give me 3000 kilograms. So ton and ton cancels out each other, and I'm going to have a required unit left. So I'm going to get the answer as 3000 kilograms. So these are the examples related to mass. Example number 10 is actually very important, and it's going to be there in most of the exams, and I have to make sure that you understand this conversion to make sure that your answers are correct in the exams. Sometimes we are going to face a problem in which there is a speed mentioned of any object. So for example, if I am going to convert the 45 km/h to meter per second, again, why do we need to convert this thing? Because kilometer is not a base unit of length. Meter is a base unit of the length. Hour is not a base unit of time. Second is actually a base unit of time. So we have to make sure that we convert this number into an equivalent meter per second. So 45 km/h, we actually have to convert two different units, which is actually at the numerator and at the denominator. So let's start with, first of all, time. So 45 km/h multiply with 1 hour has 60 minutes. So our hour cancels out. We actually reach 2 minutes. Now 1 minute is equal to 60 seconds. So 1 minute is 60 seconds. So minute will cancel out. My desired unit is achieved, which is second, and in the denominator. Now I have to do something about kilometer. 1 kilometer is again 1000 meters. So kilometer cancels out. If I'm going to divide and multiply with these numbers, I'm going to get the answer as 12.5 meter per second. Now there is a general rule, or you can say as a shortcut, to convert from km/h to meter per second. That shortcut is actually derived by simplifying these conversion factors together. Together. So as a general rule, when you want to convert the km/h to meter per second, divide that number by 3.6. So for example, if you want to directly jump to the answer from km/h to meter per second, 45 divided by 3.6 is going to give you 12.5 meter per second. And again, if you want to convert from meter per second to km/h, you need to multiply by 3.6. So this example is actually very important in the case of further chapters which we will discuss later on in this course. So km/h to meter per second is the most important conversion. So that's why it's worth it to mention a general rule for that. But again, if you forgot this number, just in case, you can do this lengthy conversion to get your desired answer. Thank you, and I will see you in the next lecture.